All right, 20 and 21 were the two that caused students and teams the most troubles. Quite a lot of you had problems with this. So let's think about this. Mel is thinking about going on a cruise. He values a cruise at $2,000 if it's nice weather, but if it's bad weather, he values it at $50. The probability of nice weather is 60%, probability of bad weather is 40%. So trip insurance is sometimes available. If purchased, it allows travelers to delay the cruise until the weather is nice. Suppose the price of the cruise is $1,200. If Mel is risk neutral, then Mel should not buy trip insurance. Only buy trip insurance if it costs less than $50. Only buy trip insurance if it costs less than $780. Only buy it if it costs. So let's think about Mel's expected value of the trip if he has no insurance, and then if he has insurance. The difference is his willingness to pay for insurance. So if he doesn't have insurance, we use the probability of good weather times his valuation in good weather. And so that's 0.6 times 2,000 plus 0.4 times 50. And then let's 0.6 times 2,000, that's 1,200 plus 20, so it's 1220. Pardon me, I didn't get my calculator out. And then if he has insurance, his expected value is he'll be able to pay for insurance and only go when the cruise is nice. So his expected value is 2,000 minus whatever the insurance pays. And I guess the expected value, we should net off the cost of insurance. The cost of the cruise too. He has to pay for the cruise at $1,200 in either case. So expected value with no insurance should be 1,220 minus 1,200. That's 20. And then his expected value with insurance, it's 800. 2,000 minus 1,200, so 800. So notice that having insurance would boost his expected value. If it were given away to him, it would boost his expected value by $780. So any price less than $780 makes him better off with insurance than it does without. So C's the right answer. That, it was a bit of work. It's all straightforward logic, but you have to know the expected value formula and then know how to put everything together. Hard to do in time pressure. So I see why so many people miss that one. Good job to those half of the teams that got, well, not half the teams. There was at least one team got it right. So good job. All right, another one. It's a similar one. Alex, he's risk neutral, looking for a one-bedroom apartment for the month of August. All of the one-bedroom are of equal quality. 70% rent for $700 a month, 20% rent for $600 a month, 10% rent for $500 per month. The first apartment Alex finds rents for $700 a month. And if the cost to Alex of searching for an apartment is $30, then searching for another apartment is a gamble with an expected value of it's just what's the he's got $700 a month, so let's think about it. It's with 70% chance he finds another apartment that is another $700 apartment, but he's got a 20% chance of being $100 a month. Oh, this is I'm surprised nobody challenged this, because we were talking about just what's the value of a stream of $100 a month payments. Let's just go forward. It's with probability 0.2, he saves $100. It's actually per month, so that and a 10% plus 0.1 times 500 per month. We've got 20 plus 50. Oh, plus that's my problem. I'm like, wait, no, these it's a $200 gain. It's actually per month. It's not. So it's 0.2 times 100 is 20, plus 0.1 times 200 is 20, equals 40. That's 40, but really it's $40 a month, and it should be $40 divided by the monthly interest rate, which actually turns out to be a good amount of value. I'd say that well, nobody challenged this, but this was one you should have challenged, because I would have challenged it on the grounds that it's either $100 per month or $200 a month gain, and that's quite different from what the problem gives you. Wow, that one's a bad one. I might just have to give everybody credit for that one.